So that's totally fine. So if your claim was H1, then you'd end up with that. Now we're going to take a look quickly, briefly, at confidence intervals. So the confidence interval for these matched pairs is exactly the same as it would be for one sample. It's going to be T interval. And again, you're just going to put in your L1, 1, and your confidence level. So let's just do one of those quickly. We'll do it together. It is this one that you just did. So the nice thing is your data is already in there. So it's just going to grab the data that you have already and plug everything in. So it's going to be super, super straightforward. Here we go. I'm going to do T interval. Because again, we've made this into one sample of L1, 1, and my confidence level. Let's go ahead and take a look at that. Okay, I have the wrong stuff in there. But you're going to do stat, test. So for mine, I would do stat, test, T interval. And again, data, list 1, frequency 1, confidence level 95%. And there I get my interval, my X bar, and my S. Yours is going to be different because this is for this sample, I believe.
Well, that was
quick. So for this one, again, we're doing a one sample t-test, or t-interval on this. So I do t-interval of L1, 1.95. Actually, this was one tail, so I do 90% there. So I'm going to change that. So I do stat, test, t-interval, because one-tailed becomes, when I make it two-tailed, becomes 0.90, 0.9. And we get an interval from negative 7.66 to 14.06. So what that says is, my interval went from negative to positive. Does it include 0? Yes. So then that means that no difference is possible. And that corresponds to what we found in our hypothesis test, that we did not have enough evidence to say that presidents differ from their opponents. So I'd like you folks now to do the same thing. And like I said, it's already in your list 1. So it makes it super straightforward and super easy to do this. So go ahead and find your interval. The tricky part is going to be these two things here. Give me the best point estimate, if you all can remember what the best point estimate is, and what the margin of error is. So I'll give you folks a few minutes to work on that. Okay, so first off, let's just see where people are so far. Make sure you're on the right page. This is 0.95. What did you get for your interval?
Negative 9,000. Oh, negative 9.9 what?
9.9. Negative 9.979.
979. 98.
3.41.
Okay, good. So this is what everybody should have for their confidence interval. And then I'm just going to remind folks about what these other pieces look like for a test. For a confidence interval. It's been a little while for a confidence interval since you've done confidence intervals. Remember, you have your kind of your p hat or your x bar in this case, maybe. And then you're going to jump back, subtract your error, and add your error to get to your upper and lower limits. All right, so if you remember from early on, we said our best guess for the average time to get to Oakland Airport is 40 minutes, and then we're going to maybe subtract 10 minutes and add 10 minutes to that to get our upper and lower limits. We're going to subtract a certain number of standard deviations and add the same number of standard deviations, right? So that's where we get those upper and lower limits from. So if you have the upper and lower limits, you can find the best point estimate. The best point estimate is the number in the middle. You can also find your error, your margin of error, because it's how far it is from your x bar to your lower limit, or from your x bar to the upper limit. Or you can look at it as being twice the distance from the upper limit to the lower limit. So you can find it any one of those ways. So I'll give you folks a couple more minutes to sort those out. All right. What is my best point estimate? Anyone?
26.65.
Anybody else have a guess? What's my best point estimate? Anybody remember what my best point estimate is? My best point estimate is my x bar or my p hat. It's whatever you got from your sample. I take a sample, and in my sample, the average height is 64.3 inches. What's my best guess at the average height of all people? 64.3, whatever I got from my sample. Does that make sense? So my x bar is my best guess at what the whole population is going to be. Yes? No?
Yeah.
Okay. So my best point estimate is going to be x bar, 16.67. What's my margin of error? It's the distance from here to here, or the distance from there to there. So I can take my x bar, subtract my lower limit, or take my upper limit, subtract my x bar, either one. I'll do x bar minus my lower limit. So that's going to be 16.67 minus negative 9.98. Minus minus means plus. So I end up with 26.65. You could also take your upper limit, subtract your lower limit. That's 2 e's, and divide that by 2. All right, so now, I just want to mention a couple things. Again, so for all of these 2 samples, chapter 9, these are the possible tests you can use. 2 proportion z-tests for proportions. 2 sample t-tests for 2 means that are independent. But if you have 2 means that are dependent, you're going to subtract them and do a t-test of the difference. Right, this is going to be when you're looking at mu d instead. This is in general all of the calculated functions you might want or might want to use. Again, the intervals always end in int or interval. The tests always use in test for hypothesis tests. Proportions will always say proportion in them. Means will always say t in them. Good. And then 2 if there's 2 of them, 1 if there's 1 of them. Pretty straightforward. On exams, I'll expect the following things. You need to do all of these steps. State H0 and H1, indicate which is your claim. Step 2, write down your alpha. Step 3, find your test stat, which is your z-score or t-score, and your p-value. And also, tell me what test you did and what numbers you put in there. I want to know that. I'm not making you folks draw a picture or look up critical values. None of that stuff. Instead, but at least show me this work here. And then step 4, either reject or not reject or fail to reject. Either one's fine. H0. Don't forget to write H0. Do it now, right? Practice it so you do it on the exam. Because if you don't write down H0, that's a point every time, every problem. If you don't write down reject and not reject, that's even bigger because that's the key part of step 4 is either rejecting H0 or not rejecting H0. H0's on trial. You're either going to reject it or fail to reject it. And then show a comparison of your p-value and your alpha. This is the justification of why you rejected or didn't reject. And then last, summarize the results for your claim and make sure you say what your claim is in there. You must state your claim. All right, we're going to grab our handout from the back on hypothesis testing, adaptive from Moscow Champs. We're going to kind of go over these two quick examples. The first one, Una, can you read for me? This one's activity 5. You can read it from your sheet too.
Activity 5, cat households, statistical versus practical significance. A national survey of 50,347 households in December 2011 found that 30.4% of American households own a pet cat.
Great. Is this number a statistic or a parameter? Why is it a statistic?
Comes from a survey.
Comes from a survey. National survey of 50,000 households. That's not all the households. That's the sample. So this is a statistic. What is the symbol for this statistic? What is this statistic? Survey of 50,000 households in December 2011 found that 30.4% own a cat. Is it a proportion or a mean?
It's a proportion.
How do you know it's a proportion? There's a percent symbol. It's a proportion. All right. So what's my symbol for proportion? That's a statistic. So is it P or P hat? Why is it P hat? So it's going to be a proportion of some sort. It's a sample. Statistic is from a sample. Everybody on board with that part? So sample proportion is what? Michael, what's the sample proportion symbol for that? Check with your neighbors.
Oh, it's P hat.
P hat.
Appreciate it.
All right, so what is our P hat? Yeah, and what is it in this case? 0.304. All right, good. Hey folks, let's go through this so that we can't waste time. Otherwise we're going to go overtime today. I don't want to go overtime today. We've got 2 things to cover here. All right, so we're going to conduct a significance test, whether the sample data provide evidence that the proportion who own a cat differs from 1/3. So my claim is what? That it differs. That what differs? The proportion differs. How do it differs?
Not equal to.
Not equal to. Not equal to what? It's not equal to what?
P.
Read it.
1/3.
1/3.
Oh yeah.
Good? All right. So my step 1, H naught is always equal. So it's going to be what?
Equals 1/3.
What equals 1/3?
P equals
P.
1/3.
P equals 1/3. Is that my claim?
No.
No. So H1 becomes my claim. P is not equal to 1/3. That's my claim. You don't have a lot of space, so I'm going to make it small. Step 2. Alpha equals, there's no alpha given, so what we're going to use for alpha? 0.05. Step 3, I'm going to do a 1 proportion test. So I'm going to pop open my calculator here. Stat test 1 prop z test. My P naught is 1/3, so I'm going to type in 1 divided by 3. Bam, it calculates for me, 0.33333. Super cool. My x, ooh, I don't know what my x is. So here I got to clear this for a second. I got to figure out my x. So I have I had 30.4%, so 0.304 30% of what? I had 30%, 30.4% of how many households?
50,247.
Yeah, so how many is that? How do I find out how many that is?
You multiply.
I multiply. My n is 5347. My p hat is 0.304. My x is n times p, which is 5347 times 0.304. So I'm going to do that. And I get 15305.48. That becomes 15305. You cannot ask a fraction of a person. If you try to ask a fraction of a person, you will get an error every time. Right? I can't ask 15,305 and a half people. You got to round to the nearest whole number. All right, so now I'm going to plug these in. Into my test, it'll be 1/3, and then it's going to be 15,305 out of 5347. Go back over there. Stat test, 1 prop Z test. Oops, 1 divided by 3. 15305, 50347. My claim was not equal to, and calculate. I get a z-score of, my z-score is negative 13.97. That's huge. I've never seen a z-score that huge. That's huge. And my p-value is, look at that, 2.59 E. Yeah, so it's not 2 point, is it 259%?
No.
Remember, anytime our p-value is bigger than 1, we should look for an E negative. E negative 44, that's huge. That's really, really, really crazy small, right? Or that's tiny, I should say. Right? This is never going to happen. This is basically 0. Anytime, heads up, anytime you have an E negative 7 or more, you can just write down E negative 7 or E negative 44. I'm not going to make you write 44 zeros and then the number. All right, so if this is 7 or more, you can just leave it as E negative that number. If it's less than 7, then you can write out 6 zeros or 7 zeros. All right, so now we're going to go to step 4. My p-value is way less than alpha, so I'm totally going to reject H naught, which means there is enough evidence to support the claim that that not 1/3 of households are pet owners, cat owners. Okay, so that seems reasonable. We rejected our own hypothesis. So the next question comes, let's make a, so definitely seems like, what proportion of people are cat owners? Is it 1/3? Is it true that 1/3 of households are cat owners?
No.
No, we totally rejected the null hypothesis. Does everyone see that? We have a z-score of almost negative 14, which is huge. A p-value, it's impossible. In other words, it's impossible that a third of households are pet owners. Everybody absorbing that? Yes? Is everyone wrapping their head around what we're saying? Okay. So let's figure out, the thing about the test is it doesn't give us, it doesn't tell us what the percentage is. It just says it's not that. If we do a confidence interval, that will tell us, give an approximation of what the interval should be. So I'm going to do this, which is going to be easy. One prop z int so stat test one prop z interval, and my stuff is already there, which makes it really easy. It's going to be 15,305, comma 50,347, and 99%, so 0.99. Calculate. And this says that it's between 0.299, so basically 30%, to 0.309, so basically 30 to 31%. Does that make sense to folks? All right, so really, the portion of pet cats is really 30 to 31%. Do our sample data provide very strong evidence that's not 1/3? Do you find strong evidence? Yes. Yeah, absolutely. What provided that strong evidence? Was it the p-value or the confidence interval that helped you decide that? The p-value. Exactly. The p-value gives us evidence. That's where we get our evidence from. So it's very strong evidence. It's the p-value. But does the sample data provide strong evidence that the population proportion who owns a cat is very different from 1/3? So 1/3 is 33%, 33.3%. We'll call it 33%. In actuality, it's 30 to 31%. Is that a lot different?
No.
30 to 31% is not that much different from 33%. It's pretty close. So does everyone kind of follow what we're saying? I mean, it's in the same ballpark. If I said, oh, about 1/3, and it's really like 30 or 31%, would you be like, no, it's what? So it's not that different. What helps you decide that? Was it the p-value or the confidence interval that helped you decide that? The confidence interval. So it's not that different. So this illustrates the difference between statistical significance. In other words, it was definitely, we had a lot of evidence that it was not 1/3, but practical difference, that's when you look at your confidence interval versus what you actually got. And practically, it's not that different. Right, so I also emphasize the fact that confidence intervals give you kind of a sense of what the actual numbers are. On the flip side, let's flip it over quickly. Female senators, we'll do this one quickly. I need a good, fast reader. Great.
Suppose that an alien lands on Earth, notices that there are 2 different sexes of human species, and sets out to estimate the proportion of humans who are female. Fortunately, the alien had good statistics scores on its home planet, so it knows how to take a sample of human beings and produce a confidence interval. Suppose that the alien happened upon the members of the 2019 U.S. Senate as a sample of human beings. So it finds 25 women, the most ever to serve the U.S. Senate, and 77 men in its sample.
Great.
Use this sample information to produce a 95% confidence interval for population proportion of all humans who are female.
Okay, great, thank you. Is this a proportion or a mean? Proportion, yeah, it says proportion. There's no mean or standard deviation. How many samples do I have? 1 or 2? 2 samples? What's my first sample?
Wait, they're all.
Men and women? That's P hat and Q hat. Does it make sense? So men and women aren't 2 different samples. Men and women are P hat and Q hat. So hey folks, try to stay focused so we don't go overtime. If I do, it's all on you folks. Okay. So one sample, good. All right, so we're gonna find a confidence interval. Let's go ahead and do that. So what's my x? Oh, it's not x bar. X is 25. What's my n? 102. Everybody on board? Because there's 102 people. So we're going to pop in here real quickly, and we're going to do stat tests. 1 prop z interval. We had 25 women out of 102, and they wanted a confidence interval that was 95%. We got 0.162 to 0.328. 9. Okay? So the percentage of women should be between 60.2 and 32.9%. Based upon your many years of living on Earth, do you believe this confidence interval provides a reasonable estimate of the population proportion of all humans who are female? No, absolutely not. Why is this a problem?
It's a bad sample.
Yeah, it's a good bad sample.
Why is it a bad sample?
These are people who are elected.
Was that?
It's not like randomly selected.
It's not randomly selected. Does that make sense? It's not a random sample. Everybody got that? Clearly, it does not make sense to use the confidence interval to estimate the population of women on Earth. But does it make sense to use this to estimate the proportion of women in the 2019 U.S. Senate?
Yeah.
15 seconds, talk to your neighbors about it. Does it make sense does this interval make sense for estimating the proportion of women in the 2019 U.S. Senate?
Yes.
No!
What?
We don't need to estimate. We don't need to estimate this.
Proportion.
We know it's 25 out of 102. Does that make sense? This is the 2019. It's its own thing. You can't use it to estimate. Why would you estimate yourself, right? I don't need to estimate. If I wanted to estimate how many women are in this classroom right now, I wouldn't need to estimate that. I could just count them. You know what I'm saying?
What if your goal was to estimate? Like,
So then you take a sample of senators, not all of them, and you can use that to estimate.
oh, okay.
This is the whole population.
How do you do
You would randomly pick, you'd write down all 102 names, you'd randomly pick a bunch of them.
that?
All right, so this one illustrates a couple things. One, it does not compensate for problems of a biased sample. If you pick a bad sample, a biased sample, garbage in, garbage out, you're going to get garbage. Secondly, don't forget that we use confidence intervals and these things to estimate populations, not things we already know all of them of. All right, great.